Hello everyone, and welcome to Lecture 8 for English 421Y. This is the first lecture for Unit 3, Incident Analysis Report. For the final unit of this semester, you will be working in groups to write a formal, long report that analyzes an incident, accident, or controversy. The goal of this project is both to give you experience developing formal reports and to challenge you with conducting research on both the causes and reporting of accidents. While you may never have to write an incident analysis report specifically, both the format and the purpose of the document transfer to other kinds of writing that you may do. For instance, in many positions, you might be expected to write about something negative that happened within your company, such as a workplace injury form, a quarterly earnings report with bad news, a report detailing the results of an investigation, etc. Such documentation is a common part of most industries, especially in the technology industry. But it's not a kind of writing that comes naturally. Describing an incident often requires relying on other sources of information to substantiate claims or provide evidence. For instance, if a rocket explodes during launch, the team investigating the cause might include in the report images and audio taken before and after the accident, data and other metrics recorded with a range of different tools, and even interviews with witnesses or those directly involved. Collecting this information and using it to present an argument and to present multiple sides of a complex situation is not something that we're used to doing necessarily when it comes to research. Describing what happened and why it happened requires a significant amount of detailed evidence, both to support a single quote-unquote official version of events and to rule out other competing narratives or plausible explanations. Such documents can also have legal ramifications, as they could be used in a trial, subpoenaed for a government investigation, or referenced in a news story. How we write about errors and mistakes is important, both for producing clear and useful reports, and for better understanding how to design objects or write documentation to avoid mistakes and errors in the first place. So today I'm going to focus in this lecture on the first reading that you will be doing for the first reading response. And this reading is Donald Norman's The Design of Everyday Things. In his book, cognitive scientist and usability theorist Don Norman examines the psychology of design and designed objects in order to understand how design can be made more useful to people while accounting for the complexities of human behavior. As Norman writes in the introduction, the problem with the designs of most engineers is that they are too logical. We have to accept human behavior the way it is, not the way that we wish it would be. The excerpts that I've asked you to read from Chapter 5, Human Error? No, Bad Design, focus on Norman's argument that often when quote-unquote human error is blamed for an accident or incident, it's usually an incomplete evaluation. If you look harder, the cause is often poor design, ineffective procedures, unreasonable expectations, and social or institutional pressure. Norman opens Chapter 5, which I'll skip ahead to. He opens Chapter 5 by arguing that in most situations where human error is the cause of an accident, the nature of the tasks and procedures require people to behave in unnatural ways, such as staying alert for extended periods of time, providing precise control of complex equipment, or multitasking when under pressure. When an accident does happen, he argues, the human cause is found and the guilty party is fined, fired, retrained, or even jailed. But removing the person who caused the problem often does not change the underlying conditions that led to the mistake in the first place. Instead, removing the person can create the illusion that the problem has been resolved, when in reality, the same error will occur over and over again with new employees. According to Norman, this quest to find the single underlying cause of a problem ignores the fact that most accidents are complex and occur when multiple things go wrong, each impacting the other in a chain, or more accurately, a web. Treating human error as the end of an investigation, Norman argues, would be like ending an investigation into a malfunctioning machine by identifying the broken part. Yes, you've figured out why the machine isn't working, but you still haven't figured out why the part broke. In such situations, Norman notes, we don't stop when we find a broken part, but instead keep asking questions until we are satisfied that we understand the reasons for the failure. Then we set out to remedy them. One strategy for identifying causes of an incident that Norman mentions is the 5 whys. These were developed by Sakichi Toyota and used by the Toyota Motor Company to improve quality. Norman describes this procedure as follows. When searching for the reason, even after you have found one, do not stop. Ask why that was the case, and then ask why again. Keep asking until you have uncovered the true underlying causes. Does it take exactly 5? No, but calling the procedure the 5 whys emphasizes the need to keep going, even after a reason has been found. By resisting the urge to end an investigation when one reasonable cause has been determined, the 5 whys reminds us that every cause has its own cause, and the deeper you dig, the more complex those other causes become. We should treat all failures in the same way, Norman writes. Find the fundamental causes and redesign the system so that these can no longer lead to problems. When the underlying cause of an accident is seen as a personal failure of one person, and not a sign of poor design of procedures or equipment, then it's likely that the next person who uses those procedures or equipment might encounter the same exact situation. If the system lets you make the error, it is badly designed, Norman writes. And if the system induces you to make the error, then it is really badly designed. In the remainder of the selection that I've assigned to you, Norman describes the 2 types of errors, mistakes and slips, explains the impact that social and institutional pressures have on the causes and reporting of errors, and identifies 3 principles for designing collaborative systems between people and technology. Ultimately, Norman argues that we should deal with error by embracing it, by seeking to understand the causes and ensuring they do not happen again. We need to assist rather than punish or scold. So this book was published 30 years ago in 1988, but it actually resurfaced earlier this year due to kind of an interesting incident. So on January 13th, 2018, residents of Hawaii woke up to see the following text message alert in all caps. Ballistic missile threat inbound to Hawaii. Seek immediate shelter. This is not a drill. Imagine waking up to that at 8 a.m. 38 minutes later, a second alert was sent informing residents that this was a false alarm and that there was no active threat. Understandably, people were panicked, then relieved, and then outraged. How could this happen? According to the governor of Hawaii, David Ige, an employee pushed the wrong button. In other words, human error. So again, while Design of Everyday Things was published in 1988, Norman made headlines, at least in the design community, when he made a connection between his argument in the book and the human error at the source of the Hawaii missile at the source of this scandal. So the article that I've asked you to read is essentially a follow-up to Chapter 5 from Design of Everyday Things 30 years later that uses the Hawaiian missile mistake as a very real and very terrifying for those who lived it example of incident analysis. As Norman explains in this article, the actual cause of the system is tested twice a day, with the person doing the test selecting the text message from a list. In this case, it is believed the person accidentally selected the wrong message. Not hard to do. He says, ever use a drop-down menu to select the name of a state and end up selecting the wrong one, usually adjacent to the desired one? For example, selecting Mississippi instead of Minnesota. Drop-down lists are notorious for leading to these kinds of errors and should not be used in safety-critical situations. Norman argues that when design and documentation, I would add, fail, it's often the users who are blamed and not the designers who created the broken system, at least at first. But often the actual cause can be traced back further to a system that led the user to make the mistake, such as the Hawaiian government employee clicking PACOM CDW state only instead of clicking drill PACOM CDW state only. This is the actual list that they clicked. While Norman offers some suggestions for avoiding such errors that are specific to design and that I think many of you would find interesting, he ultimately uses the example of the Hawaii false alert to remind us of an important point and to reiterate an argument made in his book. We know how to prevent errors, such as the false Hawaiian missile alert, he says. Design assuming that people will err when taking actions under severe emotional stress and in a rush. Make sure that a single person's actions cannot lead to harm. Test the resulting design under conditions as real and as difficult as possible. Systems seldom work as the designer intended them to. That's why we test early and then test throughout the design stage. So you might be wondering, what does all this have to do with technical writing? Why are we talking about design and error and incidents and accidents in a writing class? As we saw in Unit 2, complex processes are usually documented through procedures, manuals, and protocols. Even for situations that could be life or death, such as sending out an emergency alert in case of an attack or natural disaster, employees are often following procedures, using a software program or tool required to do their job. Both the procedures and the software or tool were designed, and if they were done so poorly, it can cause accidents. For our current project, when writing a report about an incident, accident, or controversy, it is important to follow Norman's advice and always consider the other factors that may have led to what appears to be a simple human error. While negligence does happen, people do just do the wrong thing sometimes. It's a researcher's responsibility to keep asking why and to always look for multiple causes, including those that are both less visible or more complex than human error, and those that are painfully simple, like the use of drop-down menus with complicated titles, causing someone to choose the wrong option of two similar options. For this project, I'm asking you to examine a particular incident, accident, or controversy by looking at how it was investigated and described in government documents, official reports, memos and letters, news articles, blogs, social media posts, and other materials. Your goal is to piece together both what happened and to get at the more complicated question of why it happened by sifting through reports that were made after the fact. As you conduct your research, keep Norman in the back of your mind as a reminder that the underlying cause is never as simple as it might seem. If one report or one memo identifies a single underlying cause, keep asking why in order to see the bigger picture. While you have the benefit of hindsight in your report, do your best to avoid arriving at overly simplistic or convenient answers, or describing complex situations and explanations with absolute certainty. Do your best to maintain complexity of the problem, pursue competing narratives, and continuously ask what else is going on, what else may have caused this, why. I want to end this lecture with a recommendation as you begin selecting your topic. One of the most common reasons that groups struggle during this unit is because they select a topic that is too large and too complex. I'll give you some ideas in the assignment sheet for narrowing topics and finding sources, but I want to briefly talk about what happens when people select a topic that is too big. So while famous accidents like the BP oil spill, the Challenger explosion, or the VW emissions scandal are not banned, they pose several challenges that make them significantly harder to properly examine in 15 pages. As Norman reminds us, most accidents have several causes. This is especially true for massive accidents like the BP oil spill, where a series of incidents over a period of months led to multiple accidents that strung together led to this huge accident. When groups have selected these kinds of topics in the past, they tend to stay too surface level and focus on too many causes and problems. As a result, their reports tend to read more like a Wikipedia entry than an in-depth analysis. If you really want to do a massive accident, you need to narrow down to one aspect of the larger incident and deliberately ignore, though in a logical manner, pieces that you don't have time to address. That is, instead of doing the entire BP oil spill, you might focus on one component of it and go into significant detail. Exactly how you narrow your topic will depend on what accident you select, but you must narrow. For For giant topics, you need to focus down. Even with smaller topics, you may need to omit some details from your analysis in order to get into greater detail in other areas. Many of you have probably already had me tell you this in comments, but it's better to say a lot about a little than a little bit about a lot. The best topics of this project are narrow in scope and allow groups to go into significant detail and really explore the complexities of both the incident and the investigation. If you find your group gravitating to these larger, more famous accidents, consider first doing some pre-search, which I'll talk about in the next lecture, to find similar incidents that are smaller, less well-known, or more recent. One of the examples that I give you in the sample projects folder was a group that originally wanted to do the BP oil spill, but after heeding my advice, they chose instead to examine the Aliso Canyon gas leak, a less famous but equally interesting and complex incident that had happened several months before the class started. And you can see in this example, it's still a oil spill, it was still a big incident, but they were able to focus on a less well-known event and go into greater detail about what actually happened. While recent events pose issues for this project as well, namely if the investigation is still ongoing, there may not be much publicly available information yet, they also tend to lead to smoother development processes and better projects. Again, massive accidents aren't forbidden, but nor are they necessarily easier, simply because there's a wealth of available research about the topic. That's it for today. As you start putting together your memos, make sure you read through the assignment sheet and take a look at some of the examples to see the types of accidents and the way that people have focused or narrowed the argument that they present in their reports. That's it for now. Everyone have a good day.